Welcome everyone to lesson 3.1.6. Today we are doing three problems that says what makes a graph complete. We're talking about a complete graph. Okay, you'll notice at the top where it says complete graph and then it says silent board game. If you're watching online, we're not going to do the silent board game, but I do want you to write at the top complete graphs have colon, and then we're going to name three things. Three things. So at the top of your paper, I want you to take these notes. Complete graphs have, and we're going to identify three things that all complete graphs have. So here we go. Just so you know, this is one of those situations where the correct answer is we don't know. Here we go. Examine the following graphs and answer the questions associated with each one. Here we go. Letter A. What are the coordinates of point A? Correct answer? We don't know. So on the graph, I want you to write, we don't know. We don't know. But why don't you know? Okay? We don't know in this problem what the coordinates are. That's x, comma, y. We don't know what they are because we don't know the scale. So we're going to write needs a scale. Now, a scale is how we count. So at the top, what I want you to write is complete graphs have scale. Scale is how we count. Okay? That's how we count. Problem number 2. Where will the line be when x equals 5? Correct answer? We don't know. So we write, we don't know. Okay, but why? Why don't we know? Okay, in this problem, if we go to x equals 5, it does have a scale, but we go down. Do you notice how the line doesn't cross x equals 5? See, what we need in this problem needs a continuous line. This is known as a line segment because it stops. Notice this previous line had arrows. Notice this parabola has arrows. That's implying continuous. It's going on forever. There's information between the dots. So it needs to be a continuous dot or continuous line for us to make the assumption of what is x equal to 5. I can't continue on because what if this is an absolute value graph and it just veers off like that? What if it's some weird problem that has like a squiggly at the end? Like you don't know. So we don't know. Okay? So what I want you to write in number 2. Better yet, I want you to write it in number 3 because this is where it should go. It needs to be continuous. Can't spell. Continuous versus discrete. We need to make the decision, is our graph going to be continuous with a line because there's information between the dots, or is it discrete? Okay, there are problems that are John's Giant Redwood, continuous in one direction, right? The big C, discrete in one direction. If you remember Newton's revenge, right, the height problem, that's a line segment problem because people have height between these two areas. You don't have a continuous height. You only have height in this section. And so we have to think about what type of graph are we talking about. Problem letter C. What is t when k is 1? Correct answer? That's right. We don't know. But why don't we know? Well, I want you to notice in this problem, the independent variable is x on the x-axis, the dependent variable y on the y-axis. Which of these variables is dependent? Which of these variables is independent? I don't know. I'm the teacher and I don't know. Why? Because it's not labeled. It doesn't have a labeled dependent or independent axis. So what we need is labeled axes. Independent and dependent. It's both, right? The independent is usually x on the side. It's always on the side, but it's usually the x. The dependent is always the y, up, down. Okay? Just for the record, I know it says axes, but it's pronounced axes. Axis with an I. Axis is singular. The English language is stupid. That's just how it is, guys. Okay. So, our three things. What makes a complete graph? Okay, three things. Scale, labeled axes, continuous versus discrete graph. Those are the three things that you need to have for today. So what we're doing today is we are practicing taking a rule, putting it in a table, making a graph. Now I want you to notice on your paper you have three graphs. Okay, let me go ahead and get these calculators out of the way. Okay, now these graphs all need to be scaled. Your papers are all blank. So go ahead and scale your graphs. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. You need to count them. They also need x and y. X and y. X and y. You need to label your axes. Scale and label your axis from the beginning. Okay? And then the third thing that you're going to do, I am going to go ahead and do, I'll do C, and you're going to do A and B. Okay? Now, I have included the calculator for you so that you know exactly what to type on the calculator. Now, the calculators that I use here in class are TI-83s. Or excuse me, that's a different calculator. TI-30s. Okay, TI-30s are these guys right here. It's the ones we use in class. If you have a calculator, that's fantastic. You can use an online calculator, that's fine. Or if you want to just do this in your head, that's okay too. I really don't care which way it is. So what we're going to do is we are going to calculate our table. We are going to find the y values using our x value. So it says -4 squared minus 4. That's -4 times -4 is 16 minus 4. That's how I got the answer of 12. Okay. Now that's all the math that we're doing. And we're going through this each time. And we're going to mark our values down. Now my table has larger numbers than yours do. That's okay. I continue with the math. -3 squared minus 4. Well, -3 times -3 is +9 minus 4 is 5. You are just writing this down. I am continuing to write. -2 squared minus 4. Notice I'm going through the same rule every time. And the math is the same every time, just different numbers. -2 times -2 is +4 minus 4, 0. -1 squared is 1 minus 4. That is subtraction to get -3. 0 squared, 0 times 0 is 0. Minus 4 is -4. You are just writing, following along. 1 squared is 1. This looks familiar. It's -3. Curious, I already had that answer. Okay, let's keep going. 2 squared is 4 minus 4. Curious, I feel like I already had this answer. 0. Let's keep going. 3 squared is 9 minus 4. Back to 5. Last one. 4 squared is 16. Minus 4 is 12. Notice how we had repeat values. Okay? This is called a parabola. Okay? A parabola is something that is created because of this exponent. And when I graph this, I know some of my numbers got erased. That's okay. Okay? And when I go ahead and graph this, I'm going to have negative 3 comma 5, negative 1, negative 3. I know that seems weird. Whoops. 2 comma 0. My apologies. Negative 1, negative 3, 0. Notice that we have an axis of symmetry. We had this problem at the very beginning of the year when we were doing the algebra walk. Now I want you to notice, we don't have a word problem, so none of this is discrete. We are assuming it is a continuous graph with lines and arrows. This is called a parabola. Okay? Now what you are going to do on your own is you are going to do A and B, and you are going to complete your tables. You're going to graph your lines. You're going to draw a solid line, put arrows on both sides because we are assuming that they are discrete. Now, here are the directions for 54. You'll notice in the bottom right-hand corner that you need to go ahead and do 54. 54 is asking you to examine these graphs. Let's bring this to the front. You are going to answer these 3 questions. How are they different? Be as specific as you can. Label the coordinates of the point where the graph crosses the y-axis. You're going to do that. Label the xy coordinates on each of your graphs for the points where each graph crosses the x-axis. These are called the x-intercepts. You need to find that information and answer it on the lines for 354. At any point, you could go back, re-listen to portions of this video, or pause it where you need to. The purpose of today is to take a rule, create a table, take the table's information, and create a complete graph with a scale, labels, and a continuous line. Thanks for tuning in today, and we will see you tomorrow.